Hey guys, this is an example for tutorial 2. Tutorial 2 is about vector resolution, or it would be more appropriate to say it is about vector resolution and addition of vectors. Alright, so let's start. So here I am showing you example for question number 1. And then I'm also going to show you an example for question number 3D. So let's look at this question 1 here. We are given two vectors here. Vector in this red color here, B1, which has magnitude 10, and then that makes angle of 30 degree here with respect to x-axis, negative x-axis. And then there's this vector in blue color, b2 equal to 4. You don't have this different color in your handouts, but this is just to make it easy for you to read. Okay, so first and foremost thing, what we are going to do is use I hat and j hat as unit vectors to represent x-axis and y-axis. Okay, and then there are 4 steps to to do. So first step is to resolve this vector 1 into component form, and second step is to resolve this vector 2 into component form, and next step is to add the like terms from those component forms, and then fourth step is to just find the magnitude of the result, also known as resultant vector. Okay, so let's look at this. Let's implement these steps. So here, let us write down all the given information. So given b1 equal to 10, theta 1. Let us say, let's label this angle as theta 1 so it would be easy to recall later on. And we are given the magnitude of vector 2, b2 equal to 4. Resolution of vector b1 into component form. You should be familiar with this as you learned about this in tutorial 1. So let's see, let's just resolve this vector b1 equal to what? b1x I hat plus b2 b1y j hat. And then this b1x is really b1 cos theta 1 here, right? So the cosine component of the vector b1. And then minus I hat, we already talked about this in the last tutorial, why we have this negative sign, really, because the vector b1 lies in second quadrant, right? And then plus, we have here b1 sine theta 1. This part is really the y component of vector b1 and j hat. Now if we substitute the values given above, then we get this negative 10, that's the magnitude of the vector, cos 30 degrees the angle we are given, and then just do the same thing here. And then after you solve this, you get this here, vector b1 equal to negative 8.66 I hat plus 5 j hat. Let's label this as equation 1 because we can recall this easily later on. So similarly, we do the same thing for vector b2. So b2 here is equal to b2y minus j hat. Since v2 does not have any components along x-axis and also not negative because this vector b2 points towards negative j direction. Okay, and then after we substitute the value, really this angle sine 90 degree here it's just to remember easily, so that this makes b2 sine 90 degree because that angle is with respect to x-axis, right? This angle has to be with respect to x-axis, and B2 makes an angle of 90 degrees with respect to x-axis. That's why we have that. Sine 90 is 1, and then we are left with negative B2 j hat here. And substitute the value of the magnitude of B2, then we get this here. B2, vector B2 equal to minus 4 j hat. Let's call this as equation 2. Now we have equation 1 and equation 2. So 2 of the steps are done. Now we are going to add like terms. Okay, so add like terms meaning add the coefficient of I hat and j hat. So adding equation 1 with 2, we get B1 plus B2 equal to negative 8.66 I hat plus 5 minus 4 j hat. This minus 4 comes from vector B2. It doesn't have any component along x-axis. So we ended up with this value here, minus 8.66 I hat plus j hat. Okay, so now let's call this B1 plus B2, this vector, as something else so that we don't have to keep writing these two different vectors, you know. So we call this sum of these two vectors as vector V. Then we can find the magnitude of vector V equal to what? Is square root of bx squared plus by squared. This comes from Pythagorean theorem. And then it's now simple. Vector V is equal to, just substitute the value of bx from above, from here, this part here, and then the coefficient of j hat is what? This part is by, which is 1. And then if we square that, and then, you know, after the calculation, we get 8.7. So that is how we can find this sum. Now we do the same thing for difference. Okay, so you guys can do this step. I'm not gonna tell about this here. I think you guys could do this on your own. The only thing that really changes is this right here, this sign, negative, right? So equation 1 minus equation 2. So this sign changes, and then the result changes here accordingly. There is a typo, I see, so please see, put a summation, put a modular sign here, okay? Not the vector, not this arrow. It should not be with arrow. It should be without arrow here. Number 3, D. Okay, so here we learn how to resolve a vector and then add or subtract, right? So here this part 3, question number 3 is a little bit of extension of what we have just learned. Instead of just 2 vectors, we have actually 3 vectors here. So look at this diagram. We are given 3 different vectors. So vector F, this in blue color, that's making angle 30 degrees with respect to x-axis. There is another vector N along this, and this vector N makes 90 degree angle with respect to vector F. And then there is another vector, this down here towards negative y-axis, which is G, vector G, okay? So these 3 vectors, when they are added together, the magnitude of these vectors is this vector S, okay? So the magnitude of these 3 vectors, the magnitude of the sum of these 3 vectors is equal to 3, and then that is represented by vector S along this direction, this thicker red arrow here, okay? In your diagram, this alpha is not given. This is something I labeled here to clarify it to you. So first and foremost step is to use unit vectors to represent x axis and y axis. Okay, so let us represent this as this side as positive I hat, and then this side as positive j hat. And now this is, you can follow this part anywhere in physics, not just in this problem, not just in this tutorial. Always write down the given information. So we are given the magnitude of vector g equal to 10. Let us say theta 1 equal to 30 degree. S, the magnitude of vector s is 3, and then unknown magnitude of vector f equal to what, and magnitude of vector n equal to what. Okay, and we know this is really, we are told at the beginning of the question, vector s is the sum of these three vectors. So let's label this as equation 1. Now again we are going to just repeat the story we have done in question number 1. So we are going to resolve the vector g into component from, and then do the same thing for vector f, resolve it into component from, and then again resolve this vector n into component form, and then add them together. And then once we add all these vectors, we want to check whether that side is same as the vector here or not, vector is. Okay, so let's see how we do that. So resolve vector g into component form. Vector g equal to what? G equal to gy minus j hat, because vector g is pointing towards negative j hat direction, and then it doesn't have any component along x-axis. So we are left here with just j hat. Okay, so the negative sign remains as it is, and then vector is g equal to minus 10 j hat, because 10 is the magnitude of vector g. That's given. Okay, let's label this as equation A. Similarly, resolve vector f into component from. I'll let you guys do this. And then also resolve vector n into components, into its components. So vector n, let's go back and look quickly to the diagram. This vector n, right, it's in the second quadrant. We are not really given this angle, but we are given this as 90 degree here, and this as 30, so we can really find this angle that I label as alpha, so alpha must be equal to total 180 minus this 90 degree minus this 30 degree, okay, which is what? 60 degree, right? So let's see, let's go back. So when we resolve this vector n into its component form, we get negative nxi hat plus nyj hat, and then this again, nx is really n cos alpha. In place of alpha we have 60 degree here, and I hat as it is, plus ny is n sine alpha. In place of alpha we have 60 degree here, and then just j hat. And then, once you get the value of this, then you will come up with, once you substitute the value of cos 60 and sine 60, you will end up with this equation. Let's label this as equation C. Now substitute the value of vector f, g, and n into equation 1. Remember the original equation we had? Go back if you don't remember this equation. Sum must be equal to, vector s must be equal to sum of these three vectors. Okay, all right. So after substitution we end up with this. So vector s equal to this part is what? Coefficient of vector I hat plus coefficient of vector j hat. Okay, please don't mind this piece of paper. I had something to scratch there and I just wanted to leave it clean. So now after substitution, let's look at next step here. You see, this vector s can also be resolved into component form, but remember the vector s in the diagram is, let's go back. In the diagram it's really just this way, right? So it doesn't have any component along y-axis, it has only component along negative x-axis. So So we have this vector s. After resolution, we get sx minus I hat plus 0 j hat, since it doesn't have any component along j hat. You don't have to really write this down. I just wrote it in case, some of you may find it confusing. So this value must be equal, this part must be equal to whatever we got here. So just copy everything from here to here. And then what is sx? So Sx is really Sx is a component of vector S along negative I hat direction, right? So that means Sx is really S cos 0 degree, right? So cos 0 is 1 and we are just left with S here. So the value of S is given at the beginning, which is 3 here. So we are just writing that here, 3, okay? And the negative sign and I hat remains as they were. That this part must be equal to, again, the same thing here. Nothing has changed, just copy it down here. Now remember, the coefficient of j hat must be equal on both sides, and then coefficient of I hat also must be equal on both sides, okay? So let's do the j hat, because we don't have j hat here, so I thought it would be, it doesn't really matter. So let's do the coefficient of j hat. So the coefficient of j hat on left side of this equal sign is 0, right? Really that 0 here. And that must be equal to the coefficient of j hat on right side of equal sign, which is this part. So this value, if we put it here, it becomes like this. And then after you rearrange this, you get this equation here. Let's call this as equation 2. Similarly, coefficient of I hat must be equal. Again, you repeat the same process, but for the coefficient of I hat, which is this guy right here, must be equal to this part here. And that's what we're writing. Let's call this as equation 3. Now you see we have these two equations, right? If, don't worry about these numbers, numerical part. Just look at this other unknown quantity, f plus some value, constant times n equal to 10, okay? And we have here some constant equal to some value f minus some value times n here. So you see these two equations are two linear equations with two unknowns. We have two unknowns, n and f here. Here also we have two unknowns, n and f. Now when you have two unknowns and you have a two linear equation, we can solve these two equations and then find the value of unknowns. So equation 2 and 3 are simultaneous equation with two unknowns. If you haven't heard about this word, simultaneous, don't worry about it. It is just talking about two linear equations with two unknowns. After solving those two equations, we get this value, f equal to 2.37 and equal to 10.13, and when we round off, f equal to 2.34 and equal to 10.1. So okay, so solving these two equations, I'm sure you guys know how to do this. So if you think you don't know, please practice it. Otherwise, just use something, maybe your calculator or Wolfram, something like that, or get some online help where you can just enter the coefficient of these unknowns and just get the value. All right, that's about it.